In this video, we are going to learn about Dirichlet conditions. So, what is Dirichlet condition means? It is used to determine whether a periodic signal can be represented by a Fourier series. Okay, whether a periodic signal can be represented by a Fourier series or not, we can easily define by the Dirichlet condition. A periodic signal satisfies Dirichlet conditions f over one period. Then the conditions are like it will have finite number of maxima and minima. Okay, let us take one graph. Let it be the graph. Okay, so the finite number of maxima minima is, this is a maxima and this is a minima, right? Only two minima and maxima. So this is the example, like we need to have finite maxima and minima. Finite number of discontinuities means, see here how many discontinuities there. It is going like this, and from here it is again falling to here, again it is rising back, right? So number of discontinuities are finite. Okay, we can easily judge by this. Absolutely integrable over one period. So in the one period of like time, it should be the absolutely integrable. So like integrable over one period, x of t dt should be less than infinite. Okay, this is known as the absolute integrable over one period in mathematical representation. If these conditions are satisfied, the Fourier series exists. Okay, now let us go for the problems. There you will get the clear idea on the Dirichlet condition. Let us see the example x of t. When t falls 0 to t by 2, then it will be the 1. If t falls t by 2 and the t, it will be the minus 1. Check it satisfying Dirichlet conditions or not. First, let us go for the maxima and minima. Here maxima is 1 and minima is minus 1, right? So it is a finite. Now let us go for the second condition. X of t, we are plotting in the y-axis, right? Obviously, and this is the axis for the time. So let us plot this. From 0 to t by 2, it will be the 1. Okay, from t by 2 to t, it is a minus 1. Now discontinuous at 0. Okay, the 0, it is discontinuing, and at the t by 2, it is again discontinuing, right? So number of discontinuities are finite. Now second condition also satisfied. Absolutely integrable over one period of time, 0 to t. From 0 to t, one period is here, this is a t, right? 0 to t, x of t dt, 0 to t, 1 into dt, it is a finite. Okay, now here Dirichlet conditions are satisfied, so it can be represented using a Fourier series. Now let us go for the second problem. Here x of t, which is a sin t. Okay, number of maxima and minima here obviously finite. Number of discontinuities means there is no discontinuities. The graph is continuing. Okay, since function is continuous everywhere. Okay, absolutely integrable. Yes, when you take the graph over one period means it is a 0 to 2 pi sin t dt. When you do so, you will get the 4. So finite value. So therefore Dirichlet conditions satisfied. So this is how this topic will be. I hope you got the idea on this. If you learned anything in this video, please do a like and support by subscribing. Thank you for watching this.